October Hoard's Dairyman monthly webinar. My name is Kylene Anderson. I am an editor for Hoard's Dairyman magazine. I will serve as the host for today's webinar, which will focus on managing milk quality. If you're listening to the presentation live, you have access to a PDF of the slides that can be printed. The handout can be found in the handout section of the GoToWebinar control panel. Additionally, if you have questions for our speaker, you can type them into the questions section of the control panel, and we will address them following the presentation. Today, we welcome Dr. Pam Ruegg to the Hoard's webinar series. Pam completed a residency in food animal herd health and reproductive management and a Master of Preventative Veterinary Medicine at the University of California, Davis. She was a professor and milk quality specialist at the University of Wisconsin-Madison, spent time in private practice and academic positions in Prince Edward Island, Canada. In 2017, she was appointed chair of the Animal Science Department at Michigan State University College of Agricultural and Natural Resources. She's active in a number of industry organizations and is a past president of NMC. Pam, welcome to the webinar, and I look forward to hearing your presentation titled Using Key Performance Indicators to Manage Milk Quality.
Thank you so much, Kylene. I appreciate the invitation. I do have to correct one thing. I came over here as chair of animal science, but in 2020, I went back to the vet school. I have what's called an endowed chair in the vet school at this point. So it is a little confusing because it still says chair, but basically it just means I get to spend all of my time on milk quality, which I love doing.
Excellent.
So, hey, thanks for the invite.
Thank you.
All right, shall I get into it?
Yeah, let's get started.
All right, I'm glad to see we've got an audience out there, and I am going to turn off my webcam, folks, so that we don't obscure any of the slides as we get into this topic. Today I'm talking about a topic called Key Performance Indicators to Manage Milk Quality, and I was telling Kylene before I started that this topic is probably will attract not necessarily as many people as if I talked about key performance indicators for how to milk cows, or if I talked about how to treat mastitis. And the reason is it has to do with data. And data is a little bit of a harder topic and not as attractive of a topic. But the reason I'm bringing up this topic now is what I'm seeing around the US is a lapse in people using DHIA individual cow data. I'm seeing a lapse in less people doing foremilking and recording cases. I'm seeing less people recording all clinical cases. And I think we need to go back to basics and think about really the process of managing milk quality and kind of why we've gotten to a point today where people kind of feel like we can loosen up the reins a little bit. And when we're still in the race, folks, we really can't do that. So I want to start off by talking a little bit about managing udder health. Any time we're looking at managing anything on the dairy farm or really in any business, we basically need to be having an awareness of what the management cycle is. Management cycle is really simple. It applies to any business. It applies to managing dairy farms. Within dairy farms, it applies to managing all aspects: productivity, reproductive performance, milk quality. But essentially, what we need to be able to do to manage our herd is we need to be able to assess performance. We need to look at those key performance indicators, KPIs, and develop specific goals, meaning not just sit and be happy with where we're at, but be continuing to move our management along toward new goals. And to move toward those goals, we need to create a plan. That plan has to have some actions, and it's not enough just to have goals and actions. Because we're humans and human nature is pretty much consistent across everybody, when we have actions, they typically don't get done unless somebody's responsible to get them done. And even when we're responsible to get them done, They typically get done right before the deadline. I'm going to give you an example. I'm a human. I'm the same as everybody. If you look at the PowerPoint slide handout from today, you're not going to see all the slides that I have because I made 3 new ones this morning. Why did I make 3 new ones this morning? Well, I planned on making them earlier, but the deadline was really today. And that's just human nature. So this management cycle where we have to have some goals, we have to then have a plan to reach those goals, we have to put actions behind those goals. And then the key, the magic is somebody's got to be responsible for completing those actions by some set deadline, where we can look at and say, hey, are we moving forward in the way we want? And that's the management cycle. And underlying this management cycle, regardless of what aspect of the farm we're looking at, is data. And so this is the process of moving forward. And, you know, I've been in this business for 41 years since I got my veterinary degree. It's unbelievable the progress we've made on it, but it's come at a cost. There's some farms that have been able to adapt and move forward, and there's other farms that haven't been able to. And a lot of time the difference is adaptability, moving forward under new circumstances, and being able to have data and assess where we're at and where we need to be. So today I'm going to be talking about specific key performance indicators for producing the kind of milk that the market needs, the kind of milk that helps us be profitable on our individual dairies. And so today I'm just going to talk about a few key performance indicators that we use in milk quality plants. I'm not going to talk about all of them out there because I don't have enough time. But, you know, some of those things we talk about would be bulk tank cell count, assessing subclinical and clinical mastitis, and antibiotic usage. Those are some of the key performance indicators that we need to assess, and those are the ones I'll be talking about today. I'm not going to talk about today milking performance, and I'm not going to talk today about bacteriological quality of bulk tank milk. Just don't have enough time. But those are also important KPIs. So we're talking about the need to monitor and manage milk quality. And let's talk a little bit about the type of data we need. One of the things we all have on our farms is the bulk tank somatic cell count. That is, it comes automatically. We're going to talk a little bit about that and why that's not enough data. We also need to have clear definitions and detection systems that allow us to know how much subclinical mastitis we have going on and to know how much clinical mastitis we have going on. And I'll show you some pretty convincing data, assuming my slides work, that will show you why even on our low cell count herds, we can be losing a lot of money from both subclinical and clinical mastitis. Then we need things like you're seeing on this slide where we've got the udder hygiene scores, where we've got some teat dip coverage, where we've got some milk microbiology. Those are recording systems that allow us to identify risk factors when our KPIs have actually shown us that we have a problem. And then I'm going to spend a few minutes on the end talking about monitoring antibiotic treatment events, because that's some data that not many of us are very familiar with. All right, I really want to stress that we need to be able to monitor, measure, and manage both subclinical and clinical mastitis events. Now, this is real data from 2 separate herds. This is dairy comp data. This is one herd up here, this herd number 3. This herd has a bulk tank somatic cell count of 109,000 cells per ml. This is a real herd. The herd below it, this demo herd 1, this has a bulk tank somatic cell count of 229,000 cells per ml. 100,000 cell count difference there. But I think many farms aren't too alarmed if they're at 229,000. They'll be like, oh, it's not that bad. That's pretty good. That isn't good enough anymore. It used to be great. It's not good enough anymore, and I'll show you in a minute why that is. But let's take a look at within these herds, herd 1 up here. This top chart shows you the percentage of the cows that have subclinical mastitis. So this line I'm drawing across here is about 16%. You'll see that this herd on average is about 8%. The red line is the, well, this is the total of new infections and the chronic cows on the farm. And then what you'll see also on the right of the screen, that's the number of clinical mastitis events. And what I want you to really notice here is these things don't necessarily track along together. This herd's been fairly consistent with their cell count, but they've had a couple of periods where they've had some real clinical mastitis problems. These two variables, monitoring the amount of clinical mastitis and monitoring the amount of subclinical mastitis, are both needed to be able to manage milk quality. This herd below that's at 229, you'll see they have about a 20% prevalence of subclinically infected cows. That means on any one day, 20% of the cows have subclinical mastitis. And what you'll see is that was fairly consistent, but look at their spike in clinical mastitis events, which really isn't captured by that subclinical. So we need data for both, because both are costly, both reduce efficiency on the farm, and both are needed to manage milk quality. So managing for high quality milk, we must look at subclinical mastitis, and the only way we can do that, well, the primary way is with individual cow somatic cell count values. However, we also need data on clinical mastitis. And to do that, that requires us observing for milk to find abnormalities and recording all, not just treated cases. And these are all things that I'm seeing people doing less of recently or cutting back on. There's less herds on DHIA with individual cows. There's less people who are forest stripping every milking, and there's less herds that are recording all their cases. At least that's my observation. And I'm really worried that we're taking a step back at a time when we really need to not take our eye off the ball. Because let's get into some of these KPIs and why they matter. First KPI I want to talk about today is the bulk tank somatic cell count. Everybody's got that. And that bulk tank somatic cell count target that we need to hit has really changed in my career. Now let's take a look at this little graph I have on here. This is the somatic cell count average from the top 10 US milk producing states from the year 2000 to 2024. And what I want you to start with is, let's look at the year 2000. I was working in Wisconsin at that time. The average bulk tank somatic cell count across these top 10 states was about 300,000 cells per mil. We look at that now and we think, wow, that's unbelievably high. Then let's fast forward about 10 years after that, 2010. We look at 2010, the average bulk tank somatic cell count across these 10 states, top 10 producing states, is about 225. The bar is shifted down. Then if we go forward another 15 years out here to where we're at now in 2024, look at where we're at today. That dotted line is the US average bulk tank somatic cell count. The green line is Michigan, the red line is Wisconsin, this orangish line up here is California, the one below that's Minnesota. But look where we shifted. The requirements for the type of milk that the market wants have gotten more stringent. That has to do a lot with our export market and the needs to be able to compete internationally with other regions. But it's also the fact that lower cell count milk is what the processors want because it makes better products, and they're trying to be competitive. So the goal today should be for your bulk tank less than 175,000 cells per mil. And I'd say for these states on the lower end, probably we should be looking at less than 150. It's important to produce milk that the market wants to buy to maintain a market for your milk, but it's also important to minimize losses due to subclinical mastitis and to reduce the need for giving antibiotics both for at the end of lactation and for clinical mastitis. And the less infected cows we have in the herd, which is reflected by this bulk tank cell count, the less our losses and the less the need for antibiotics. Now, how do we impact the bulk tank somatic cell count? Well, the bulk tank somatic cell count is driven almost exclusively or very much by the percentage of the cows in the herd that have subclinical mastitis. And this is really consistent. Now, let me orient you to this graph. The vertical axis here is the percentage of cows in these herds. Each dot is a herd. That's the percentage of cows that have individual monthly somatic cell count values greater than 200,000. So each one of these dots is a herd. They're all, I think the average herd size here is 8 or 900 cows, somewhere in that range. And there's a couple things I want to point out. First of all, 60% of the variation in the bulk tank cell count is explained by the percentage of cows in the herd that are over 200,000. And you'll say, well, you know, I'm a low cell count herd. That probably doesn't apply to me. It absolutely applies to you. Look at these herds. There's 40 herds here. And what you'll notice is there's only one of them with a bulk tank cell count over 200,000. The rest of them are all very low, and over half of them are less than 150. Even in these low cell count herds, your bulk tank cell count is going to be impacted by your cows that have subclinical mastitis. Cell count over 200,000. You can see that right down here. If you look at the herds that are at 125 versus the herds that are at 75, that line goes up. So the way we produce high quality milk is we minimize the number of cows in the herd that are above 200,000. And to do that, we've got to have that data. Now, there's another factor that is associated with our bulk tank cell count. This is another regression line, but there's a little bit different relationship here. Here, I've got the bulk tank somatic cell count on the vertical axis. And on this horizontal axis, what I've got is your percentage of your herd that we're defining to be a chronic cow. Now, chronic cow, all I'm defining this by is monthly somatic cell count values. And I'm defining it pretty liberally by saying any cow that has 2 consecutive months of testing above 200,000 is a chronic cow. That's a pretty stringent definition. But what you'll see is 54% of the bulk tank cell count is defined by the percentage of cows in your herd that have a high cell count and maintain a high cell count. And what you'll see on that is that line goes straight up, and it's at a very low proportion. When we get to 150,000 cells per ml, what you'll see is you should have less than about 9% of your herd. So what's your goal for chronic cows? The KPI should be less than 9% of the cows that are tested 2 consecutive months should be chronic or maintain high cell counts. This is a really important KPI to manage. The cows that become chronic are the cows that infect other cows, and they're the cows that produce the least amount of milk. All right, that's bulk tank cell count. That's our first KPI, and that's the one we look at as an indicator. Let's move into our second KPI, and that's managing subclinical mastitis. Just want to spend a minute, make sure we're all on the same page with using monthly somatic cell count values. So what I've done is I've made a little pretend herd just to show you what the definitions are. My little pretend herd has 10 cows here, and we've got 2 months of consecutive testing, and then we got the status for August. So cow 1, her cell count was 50,000 in July, 70,000 in August. Both of those values are less than 200,000, so she's healthy. She was healthy in July, she's healthy in August. Let's go down here to cow 3. She was 80,000 in July, she's 700,000 in August. That's a new infection. Clean, new. In both instances, that milk's going to look completely normal. You can't see this, you have to test it. This cow I've been a little bit lenient with She was a cow that was 300,000 in July, and she's dropped to 205,000 in August. That's a spontaneous cure. On your DHIA values, it'd have to be about 199 or less to count that as a cure, but that's a cow that's going in the right direction. And then down here, this cow 5, 6.1 million in July, 3 million in August. That's a chronic cow. Those are those cows that we should have less than 9% of in the whole herd. So subclinical mastitis is, the milk looks completely normal. This cow right here at 6.1 million is going to look normal. If it was 10 million, it'll still look normal. That milk looks completely normal, but it's got too many white blood cells in the milk. Those white blood cells have moved there from the bloodstream to engulf and destroy bacterial infections in the mammary gland. A quarter can have millions of somatic cells and have normal looking milk. We have to test the milk from individual cows in order to detect it. Can't see it. You can do a CMT test if you've got an automatic milking system. There's other biomarkers in the automatic milking systems that kind of equate to somatic cell count, but you must test that milk and find these cows. There's no other way to find it. It's also really important to understand that that milk, those quarters that these somatic cell count values that we're managing, those are composite milk samples. That means there's milk from all 4 quarters taken in that sample, which means to get to this magic 200,000 threshold where we say, oh, that cow likely has subclinical mastitis, you've got to have at least 1 quarter hit 800,000 if the other 3 quarters are healthy. So when we see that value hit above 200,000, we are very confident that we've got a subclinical mastitis infection. And it matters. It matters because of our bulk tank, but it also matters a lot relative to productivity in our herd, because every time that cell count doubles above 100,000 cells, 100 to 200, 200 to 400, you lose about 2 to 4% of your production. About 0.4 to 0.5 pounds per cow per day is dropped every time you double. So this would be, let's say, half a pound here, another half a pound here, another half a pound here. That's every time it doubles. You lose 2 to 4% of your production. So it impacts your bulk tank cell count and it impacts your productivity. It also impacts the efficiency of production on your farm relative to greenhouse gases, relative to just your overall nutritional efficiency. All right, those are the definitions. Unfortunately, subclinical mastitis is amazingly common. Just last week, I went to the DRMS herd performance summary site and I updated some of the metrics. This is current metrics for October 2025. Let me orient you to this. This green bar goes with this axis that's on your right. That's the overall average somatic cell count for the herd. What you're looking at here is the average somatic cell count by herd size categories. There's about 5,725 herds in this data set as of October. And what you'll see is the smallest herds, the herds that have less than 32 cows on average have have less than 50 cows, have on average about 32% of the cows, a third of the cows, have subclinical mastitis. These values decline till you get out here till about 1,000 to 2,500. When you get out to this range, drops to about 20% of the herd on average have subclinical mastitis. Let's just think about that for a minute. That means if we went around the whole United States and we measured the amount of subclinical mastitis using cell counts, somewhere between 20 and 30% of the cows every single day have subclinical mastitis. But we don't know this if we're not doing monthly somatic cell count testing. Now, there are a bunch of herds who are fantastic at managing milk quality. This line shows the top 20% of the same herds for bulk tank cell count. And what you'll see, the top 20% is very, very consistent across all of the herds. They're running about 175 or 150 or less in bulk tank. And when you get out here, it's close to 100,000 on bulk tank. So there's lots of herds that know how to manage udder health and are doing it really, really well. So that's kind of the data we're looking at on these farms. All right, let's think about what these KPIs are for prevalence. For subclinical mastitis, the prevalence, that's the percentage of the cows that have somatic cell counts that are above 200,000. The prevalence should be less than 15% of the lactating cows. Go back here and you can see what prevalence is on these herds. We're getting out here into about 20% with these cell count values down here. By the way, I think I misspoke. Sorry about that. This is prevalence. The green bar goes with the left. This is prevalence, 30% of the herd, 20%. This bar, this is the bulk tank cell count that goes with that. Apologize for that. This dotted bar, you'll see the bulk tank cell count 250 to 200. Top 10%, 20% of the herds are down here under 100,000. Just want to make sure you guys are paying attention on this. So prevalence should be less than 15%. Incidence, that's our new infection rate. Okay, listen, this is printed on DHIA sheets. You can get this from DairyComp, PC Dart, and all the other herd management software. The incidence is the percentage of cows that are developing new subclinical mastitis infections. That is calculated based on 2 consecutive months of somatic cell count testing. And only the cows that are eligible to get infected are included. So they have to be a cow on month 1, the previous month, had a cell count that was healthy, less than 200,000. But on month 2, those cows have gone above 200,000. And so that will tell you how your current preventive program is working. And I'll show an example of it in a minute. That value should be less than 8%. This is the number one. Prevalence is the number 1 KPI to monitor. Incidence is the number 2 KPI to monitor. And there's one more that I don't have enough time to spend too much time on today, but that is prevalence at the first DHIA test. So that's the number of cows at the first test that are above 200,000. Prevalence for older cows should be less than 15%. Prevalence at the first DHIA test for first lactation animal should be less than 10%. So prevalence, percentage of cows that are affected, incidence, healthy cows that are developing infections, less than 8%. Prevalence at first DHIA test, 10 to 15%, depending on lactation. And then the percent chronic, less than 8 or 9%. Let's look at some real data. Here's these 2 herds that I showed you earlier. This is herd 1, this is herd 2. Let's just look at herd 1 for a minute. Herd 1, this is real data, got a bulk tank cell count of 229,000. This is a 7,000 cow herd. They've got about 7,000 milking cows. Bulk tank cell count is 229,000. They're milking 96 pounds per cow per day. Sounds pretty good, but their prevalence is 19%. This is their dairy comp. This prevalence is the combination of the chronic cows in red and the new infections. So the cows that have had 2 consecutive months high, the cows that have 1 month high come out close to 20%. And then the orange bar is the first test animals. Remember, we'd like that to be less than 15% for the older cows, less than 10%. You can see all of their indicators are off. They don't look too bad though. If you went to this farm and said, hey, what's your bulk tank cell count? They'd be like 229. What's your milk yield? 96 pounds. You're going to say, oh, they probably don't have problems. They're doing okay, but they could do better. They're losing a lot of money because 20% of the cows are underperforming due to mastitis. Herd 2, this is the herd that's got a bulk tank cell count of 107,000. This herd is milking 10 pounds more, 106 pounds, and their prevalence is less than half. It's 8%. Look at the difference. The red bar, the chronics, and the yellow bar, the new infections, all much lower. And look at these fresh animals, about half of what the other herd is. Both herds would meet the criteria for producing milk, but this herd is going to be doing it much more efficiently because their cows aren't spending their energy and their nutrients fighting off new infections. All right, let's go on. So what are some interventions we can do? It's not enough just to manage data. I'd say the number one thing you can do if you're looking at, if you're listening to this webinar and thinking, well, that's a lot of data, what should I do? I'd say the first thing you need to do is go in and identify your chronic cows. If you don't have DHI testing, that means you should get monthly somatic cell counts for a couple of months and find these cows. Chronic cows are really costly in a dairy herd because they increase your bulk tank cell count. They're infected long term, so they're shedding bacteria in milk and they infect other cows. They produce a lot less milk because remember, we've got that 2 to 4% reduction in milk yield every time the cell count goes doubles after 100,000. They have more clinical cases. They require more antibiotics. They require dry cow antibiotics, and they have low conception rates. So you take a look at a cow like this one. Here's her monthly somatic cell count. 9 days in milk came in at 1.6 million. She basically almost never dropped below that. So this is a cow that even though you'll take a look at her milk, it's not bad, but it's not outstanding. When you look at a cow like this, these are the cows we need to identify. And beef prices are really high right now. It might be better to fill her slot with a healthy younger cow. So who should you think about culling? If we're looking at culling chronic cows, I would say you want to cull all cows diagnosed with Mycoplasma bovis, all cows diagnosed with Staph aureus, all cows diagnosed with Prototheca bovis. The reason is it's almost impossible to cure these cows, and they are infectious to others. So you really don't want to keep them in your herd because you'll end up with more new infections. You want to consider culling cows that have multiple quarters affected by mastitis. And the reason is every single quarter got independently infected and every single quarter has to independently cure. The odds of that happening diminish the more quarters are infected. You should identify and segregate or consider culling cows that have more than 2 clinical cases in one lactation. I'll get to clinical mastitis in a few minutes. But if you're throwing milk because it's abnormal or treated and you've thrown 8 or 10 days of it and a cow comes back and with another clinical case, it's very, very hard to make up the amount of money you've lost by tossing your milk. You might as well get rid of that cow. You might want to consider getting rid of older cows that have more than 3 somatic cell counts over 200,000. An older cow that has a high cell count that isn't dropping is unlikely to respond to interventions, and she's infectious to other cows and she's producing less milk. And then you want to look at getting rid of the cows that, if you have a cow that dries off with a high cell count, receives antibiotic dry cow therapy, and then calves in the next lactation, again infected, really, please don't breed those cows. Please don't keep those cows. Put them in a segregation pen if you want to keep them and milk them a while. Milk them last, but get rid of those cows because the odds of an intervention curing that cow diminish the longer that they're infected. All right, that was our second KPI about subclinical mastitis. I got 2 more KPIs I want to cover, and I lost a little time trying to get the technology to work here. But the third one is clinical mastitis. Now remember, we talked about I'm seeing less people using monthly somatic cell count values. Here's another negative trend I'm seeing. I'm seeing less people stripping the cows every single milking and recording the cows that have abnormal milk. And this is a really important thing to do. We must train our milking technicians to detect clinical mastitis. And the only way we can detect all the cases of clinical mastitis is to make sure we look at that foremilk before each milking. Ideally, you want 3 streams of foremilk removed. You want to take a look at it onto the platform of the milking parlor before milking, because it's the only method to detect mild cases. And if you're not performing it, you'll miss at least 50% of the cases. Now, some people say, I just can't make this work in my parlor. And while the goal is to strip and observe the milk every single milking every day, if you can't get that done, at least do it sometimes. Once a day, once every 2 or 3 days, sometime to be able to detect these cases. If you are milking and observing the milk, what we tend to see is a incidence of 25 cases per 100 cows per year of clinical mastitis. Incidence means first case only. Here's another key thing to remember about key performance indicators. You need to monitor the first cases of clinical mastitis separately from the recurrent cases. So you want to really focus on preventing those first cases. Once a cow gets a first case, her probability of having a second case goes up exponentially. So our goal has to be to monitor and prevent first cases. Let me orient you to this slide. This is another 40 herds. And what you'll see here on the vertical axis is just the percentage of milking cows. Each one of these lines is the percentage of cows that had, or what this is first cases of clinical mastitis divided by the number of lactating cows, average number of lactating cows. So in this herd on the far right, 80% of the cows that lactated recorded a first case of clinical mastitis. On the left down here, this was about 5 out of 100 cows had a case. Up here, it's 800. You can see that our goal is about 25% on average, and this is consistent around the world. On average, somewhere between 20 and 25% of the cows each year will have a first case, and these little dots are recurrence rates. Just to make it simple, the data falls out that about 25% of cows that get a first case will get a second case within about 90 days. That time window is 14 to 90 days after the first case. So less than 25 cases per 100 cows per year, and less than 25% of the cows that get a first case should have a second. But to make that data work, you have to find and record all the cases, because most clinical mastitis is non-severe. And so here's the severity scoring system that's been used all around the world. Mild cases, abnormal milk only, udder and cow look normal. That is 50% of clinical mastitis cases. Moderate cases, abnormal milk, swollen udder, cow looks normal. That's at least another 35. The non-severe clinical cases are 85% of the cases. Severe cases, the ones we remember where these cows get really sick and require an emergency intervention, those are less than 15% on average of all the mastitis. So if on your farm, 50–60% of the cases are severe, that's telling you you're missing almost all the moderates in the milds, the non-severes. Very, very important to record all the cases. So here's some KPIs for clinical mastitis. Incidence rate, number of first cases, less than 25 cases per 100 cows per year. Recurrence, of first cases, what percent recur? Less than 25%. If you want another couple of KPIs, you could look at who's in your hospital pen getting milk discarded, should be less than 1.6% of the herd. And you can be looking at what proportion of your overall cases are severe. That should be 5 to 15%. All right, those are our KPIs for managing mastitis. I want to spend about 5 minutes, and then I'll leave some time for questions, talking about KPIs for managing the antibiotics we use on our farms. This is an area that most people have no idea how they compare to their peers. And this is an area that increasingly we're getting both legislative pressure and we're getting pressure from milk purchasers, the supermarkets, the McDonald's and such. So we've got to start making sure that we're also understanding on our farms where we fit relative to antibiotic usage. This is some software we created. This is open access software. Virtually anybody in the US could use this. Look up Top Milk. If you're interested, shoot me an email. We can get you hooked up to do this. But let me orient you to this. This vertical axis is the number of defined daily doses of antibiotics per cow per year. That's a metric used around the world to measure antibiotic usage. It's basically saying how many days per year is an average lactating cow getting an antibiotic. And dry cow therapy counts as 4 doses if you're giving it to a cow. So a standard defined daily dose would be the dose of an antibiotic you give to a cow in 1 day. And when you take a look at that, this is about 100 herds who benchmarked antibiotic usage in our software, and it comes out to be about 4.5 defined daily doses per cow per year. The orange bar, dry cow therapy. You can see that for most of the farms that are in the average or better than average usage of antibiotic, almost all of their doses are this orange bar, which is dry cow therapy. And then the blue bar is treatments of clinical mastitis, and the green bar is injectable antibiotics. However, when you start looking at the side where we're moving over here, dry cow antibiotics stays the same, but we get a lot more intramammary treatments for mastitis, and on some of these farms, a lot more injectable doses. So a really simple thing to look at on your farm is how many antibiotics are you using each year, and can you improve? And one of the big reasons on improving is to save you a lot of money. And I'll spend just a couple minutes showing you how that works. You want to benchmark, this isn't a benchmarking webinar, but if you want to benchmark, you can go to our website. You could end up on a graph like that in about 30 minutes. Pretty simple. You use your herd management software, you cut and paste some prompts, you answer a few questions, you extract a file from your herd management software, and then you upload it to the software. And then you end up with a report that puts you on the chart, says this is your herd or this is your herd, and it gives you some other details. And one of the details it'll give you is it'll tell you how much money you're spending treating mastitis and on dry cow treatments. So let's walk through it. This is part of a real report for a farm. This farm shows you how much money you spent per case of mastitis. So it says your farm, on each case, you spent for drugs and milk discard about $190. In our data set, the average is $209. And so, you're not spending as much as many. And this is one of the reasons. Your average milk production is about 98 pounds, but you're discarding only 7.9 days. That includes the number of days of treatment plus your milk discard. So because you're a little less than the average, 8.2, your costs are a little less. So you can come up with finding out how are you doing relative to the costs and the number of days of treatment on your farm. Why is that important? Well, you can find out how much you spend on drugs and milk discard. And what we found when we've done this is a lot of variation. This is 40 farms, and we're just showing the amount of money spent on farms discarding milk to treat mastitis, intramammary antibiotics, and injectable treatments. The average is $192 per case, but we've got farms out here spending $325 per case. And so there's a lot of upside for about half of the farms or a third of the farms in looking at, can we reduce the costs and still have good outcomes by working with our local vet on reducing, maybe tweaking our treatment protocols. Here's the type of report you'll get. This is real data from a farm. This shows you just the amount of milk withhold and medication costs. So let me walk you through this. This farm did 1,032 treatments for clinical mastitis. They spent $195, 558 on drugs and on milk discard. And then this is an estimate. This farm this is the actual drug they use. They use Spectramass. They produced 98 pounds per cow per day. They entered their milk price. It was $21. And this is an estimate that if they used the minimum label duration on Spectramass, which is 2 days, they would save about $80,000. Not saying they need to go to 2 days. I'm just showing the label for Spectramass is 2 to 8 days. And within the defined label, there's about an $80,000 difference. Might want to not necessarily think of going to 2 days, but maybe if they're at 5, they could go to 4. All right, I'm going to wrap up on this slide so I have time for a few questions. If your routine treatment protocols for non-severe clinical mastitis are longer than the minimum label discard, you can save money by considering just reducing your duration treatment by 1 day, or trying a shorter duration treatment, maybe just for lower risk cows, first lactation animals that have their first case. You can learn that by doing some benchmarking of your antibiotic usage. All right, let me wrap up. I've covered just 4 KPIs. I could talk about another 4 or 5 of them, but it's really important to make sure that we're managing milk quality by using data. And to use data, we have to have it and we have to record it. We want to be able to use this management cycle where we benchmark, have goals, have actions, and evaluate and keep moving forward. Because remember that bulk tank cell count I showed you. 20 years ago, our goal was 300,000. 15 years ago, the goal was 250,000. Now, our goal is about 175. If we want to stay in this business, we have to keep doing better. So our bulk tank cell count goals are always getting lower. And the way we influence that is by reducing the number of cows that are infected subclinically, because that subclinical mastitis will influence the cell count, the productivity, your odds of conception, your risk of culling, and your milk value. That's just subclinical mastitis. When we look at clinical mastitis, we got to have the data. You've got to be forest stripping. You've got to be observing that for milk. You've got to be recording that. It's especially important so we can find the chronically infected cows so they don't infect others. Then finally, if you're doing these others, think about benchmarking your antibiotic usage. It's very likely you could save some money by slight alterations in how you're treating mastitis, either clinical or at dry off. We've got more, I'm interested in this. I've got more KPIs on our YouTube channel and on our website. This is my team that does all the work while I get to spend time talking to people and coming up with more ideas and looking at data. I want to thank them very much. And I appreciate your joining and especially hanging on during our slight technical problems at the beginning. I think I've got time for just a few questions. Thanks.
Thank you, Pam. Would you mind advancing? There you go. One more slide, I think. To view this webinar again, or any of our previous webinars, you can visit our archives at any time at www.hoards.com/webinars. We hope you make plans to attend our next webinar, which will take place on Monday, November 10th at noon Central Time. Amber Fredrickson and Mike Hutchins will discuss a feed and forage outlook for the year ahead. And then in December, we'll be discussing beef on dairy. So we've had a few questions come in, and I'll kind of start with them kind of in reverse order from the topics that you talked about. Let's go with this first one, which you talked about antibiotics. So the question is, if you treat at dry off with antibiotics, Does it make sense to use a teat sealant as well, or is the use of a teat sealant another infection opportunity?
That is a fantastic question, and I'm going to give a highly unsatisfactory answer. It depends. And so really what the teat sealant does is there's two real things it does. That teat sealant sits in the base of that beet, and it reduces leakage at the time of dry off. And leakage is a huge risk factor for entry of pathogens into the udder. So it helps reduce leakage, and it protects from intramammary infections during that high-risk period before that keratin plug has an opportunity to fill in. The importance of that internal teat sealant depends on two things. How good are you at drying off cows? Do you have a lot of cows that are leaking? And secondly, how clean is that environment that you're moving them into? So there's, I think that the national stats on internal teat sealants is about half the herds that use them and half that don't, the last numbers I saw. So there's clearly a bunch of herds that that seem to be able to manage without them. But I will say the data is also quite consistent on them. If you've got a high-risk environment, if you've got high-risk cows relative to teat leakage after dry-off, those teat sealants are effective at reducing the risk of new infections.
Fantastic. All right, we have two Staph aureus questions.
Mm-hmm.
First one, I'm working on a Staph aureus problem in my herd. I'm culturing all fresh heifers and also cows that are 200,000 plus for 2 consecutive tests. For those cows who come back with no growth, should I continue to try to get a positive culture on them or just go ahead and assume they have Staph aureus?
It's a great question also. Those no growth culture results in a quarter that's a high somatic cell count is completely different than a no growth culture result in a clinical case. And they're really frustrating. So a couple things. If an animal, if a quarter always maintains a high cell count, like if you're doing CMT testing on a quarter and it's always high and that cow's cell count is always high, that's telling you that there's a bacterial infection out there that's stimulating an immune response. The cell count is that immune response, and that cell count will diminish if it's successful and the bacteria go away. With Staph aureus, these Staph aureus are super smart bacteria. They become highly host adapted on some farms, and they're able to kind of hide from the immune system. So if the cell count remains high, if it's CMT positive in that quarter consistently, but it's culture negative, and you know you have Staph aureus in your herd, I'd consider that to be a Staph aureus quarter. I personally wouldn't continue to try to culture. And the reason for that is I have cultured some of those quarters 5 or 6 times and had them always come back culture negative. And you've got to catch them on just the right day to be able to catch them when they're shedding.
Yeah, they're very sneaky, it sounds. Next question on Staph aureus. Would you bother culling Staph aureus cows if your bulk tank somatic cell count is 80,000?
Yeah, that's a great question. That is almost exactly our MSU dairy herd. We were a National Dairy Quality Award winner last year. And our policy at MSU Dairy is we cull all our positive Staph aureus cows. And it's a added insurance. Now we've just expanded. So as of about 2 weeks ago, we kind of amended that policy. We now have a segregation pen that we're not breeding in, that those cows that are pregnant, we're going to calve them out, keep the cat, or either keep the calves or whatever, but then get rid of them. But if you've got enough heifer replacements coming in, if you're otherwise in good shape, I would advise you to continue to cull them. Is the risk as great in an 80,000 cell count herd? No, because you're doing obviously a lot of other good stuff to reduce the risk, but there still is a risk.
Great. Another question came in on recurrence of mastitis cases, on culture negative cases on a farm that do not treat with antibiotics, does the prevalence of clinical cases increase due to this practice? Or is there going to be greater odds of severe cases?
Okay, good question as well. We have a lot of data on that. On herds that with we're talking non-severe clinical mastitis. If you've got accurate detection, in other words, you're force stripping every cow, so you're catching them early on, and they're truly non-severe, meaning that the cow is otherwise healthy. The only thing you have is either abnormal milk, a swollen quarter, and maybe a drop in milk yield. A very small proportion of those animals, 5–8% of them, may progress. And that will be more likely in older cows and more likely during periods of heat stress, things that influence the cow's immune response. In a herd that has a normal kind of distribution of pathogens, culture negative cases do not recur at higher rates than other cases. In fact, the culture negative recurrence rate is typically lower than like gram-positive cases that require treatment. So if you want to do a no culture or a no treatment strategy, the culture negative ones, especially in younger cows, are the safest ones to select. I would say when you're doing a no treatment strategy, make sure you're selecting cows that are otherwise healthy. Because when we don't do a treatment, what we're doing is we're putting all of our money as a bet on that cow's immune response. So if it's 105 degrees out, if she's a 6 lactation cow that just had twins and has a retained placenta, if she's mildly hypocalcemic, none of those things would be a good indication that she's going to be able to mount an immune response. So we still have to look at the cow and make an assessment of her capabilities.
All right, I have one more Staph aureus question, and then I think we'll wrap up and get the other questions answered offline if that's good with you.
Yep.
All right, Staph aureus detection, PCR versus culture from individual milk samples. What to do if PCR is positive and the culture is negative? Call or not to call?
So the PCR is positive,
And
the culture is negative. And this is I'm assuming this is a cow that's got a high somatic cell count. If you've got a cow with a high somatic cell count that fits that criteria, PCR positive, culture negative, and you collected that sample aseptically, meaning you cleaned the teat, it's from a single quarter, I would be confident in that result. If the strategy on the farm is to cull them, I would cull her. If you took a sample through meters, if the cows, so it's not a sterilely collected sample, if the cow has a low somatic cell count, I would not be confident in that positive result. So you've got to look at the quality of the data you have. And if you're wondering, you can always take another sample, make sure it's taken aseptically, do a CMT to find the right quarter, and submit a quarter sample for PCR. If it's positive, again, you can be fairly confident she's positive for Staph aureus.
All right, I lied. There's one more question I thought was relevant that I think we should get answered live. What would you say is the challenge between using SCC from DHIA versus robotic systems?
Yeah, wow, that is a great question. These are all really good questions, folks. The data on robotic systems is challenging to use. It is usable, but it's challenging to use. Every manufacturer has a different algorithm for their alerts. And then you can adjust the algorithm depending on how many cows you want to go out and find. So the difference between like monthly DHIA and automatic milking systems is really the sensitivity and specificity. So sensitivity means you're finding all the possible cases. specificity means when you get an alert, that cow likely has mastitis. DHI monthly somatic cell count testing is not very sensitive. It's a once a month test on composite milk sample. So if that once a month test on composite milk sample is over 200,000, and then you test her again next month and it's over 200,000, you got 2 samples from all 4 quarters, it's above 200,000, you're pretty confident that cow's got a subclinical mastitis problem, meaning it's very specific. So we don't find all the cows, but we find the cows that we need interventions on. The challenge on the automatic milking systems is you're checking every milking, and it's highly sensitive, but it's not specific enough. So what you're doing is you're getting a lot of alerts to the point of maybe you're getting a little burned out where you're not checking all the cows. So it's harder to figure out who has a real infection relative to cows who have a short, successful immune response where they're naturally eradicating a small infection. So it's a different management system. Can be done, but they don't actually have the same characteristics, and it's much harder to figure out how to appropriately use the automatic milking system data as compared to the 50, 60 years of experience we have on using DHI monthly values.
Thank you so much. We had a lot of great questions come in, and as I said, we'll send an email wrap up with the Q&A for the answers, the questions that we did not get to live. So again, thank you for your questions. And thank you, Pam. This was a fantastic presentation. And to all of our listeners out there, we thank you. We appreciate the time that you spent with us today. Hope to see you in the audience in a future Hoard's Dairyman webinar, or in the meantime, tune into the Hoard's Dairyman podcast, which is available on YouTube or your favorite podcast player. Until next time, goodbye from us, from the team here at Hoard's Dairyman.